Good morning, guys. I hope you are all doing fine. Since we are a bit behind the schedule, so I would like to start the lecture right now. If you have questions, please feel free to ask. I'm not going to do a kind of a review of the previous lecture, so you may, if you have problems regarding topics we covered in the previous lectures, please watch the videos on our YouTube playlist. Now I will directly start discussing tree traversal. So we said that there are trees and rooted trees, and we want to sometimes visit all the nodes of the trees. And since usually we store information inside these trees, inside these nodes, and at some point of our algorithm, we would like to go into the details of these nodes and get the required information. So that's why we need to have kind of traversal, a kind of a rule for that. And these procedures are called as tree traversals. And in that traversals, we need to visit all the vertices, all the, let's say, nodes of the tree. And we will be discussing some basic traversal algorithms in order, post-order, pre-order, and depth first search, breadth first search kind of things. And they are all examples of traversal algorithms. Now we will first go into these three. If you remember on Tuesday, we discussed pre-order traversal, but I will go through it since I think it was a quick covering. So I would like to consider some important points once again, and then discuss in-order and post-order traversals. So that's the first one, pre-order traversal. I'm skipping this. Maybe I may focus on it in the next one. So I'm not discussing the first part. The thing in here is that the rule is we should be visiting it actually first the root and then the left submost tree, left subtree actually, T1 in this case. And then if there are no children of T1, then we can directly cover T1, T2, and up to Tn. If you remember, I said that if we just have this part of a tree, then the pre-order traversal will be A, B, C, D. But as you see, we have more complicated case. Then what we are going to do, we will try to go into the deeper of our tree and then come back and see if there are any unvisited nodes according to our rule, and then complete this pre-order traversal. So as you see, it's written here that it will begin by visiting the root, which is R in our case. So this is the first point I'm visiting. And then going to the T1, this is the leftmost subtree. As you see, it continues by traversing T1 in pre-order. This is important. We will be traversing T1 in pre-order. Since T1 has some children, so we should continue visiting children of T1 in pre-order fashion. But as we have seen in the simplified tree, if you don't have any children anymore underneath this region, this level, then you can continue with A, B, C, and D. But now, since we have more children underneath, I will go into deeper as possible. Yes, I visited the root R. Now I'm visiting T1, which is B. And since B has T1 and T2, so I will continue visiting T1 of B. And then since E has T1, I'm continuing with J. But now, as you see, I don't have any more children, which means that T1 of J is not available. So what I do, if this is T1 of E, then I can continue with the sibling of J, which is K. So I will continue like this. And then since K has some children, so I will visit N first, and then O, since O and P are siblings of N. So we can say that they are T2 and T3. This is how I do the visit. NOP. And then what is the next item? If you look at the top of this point, actually this node, since every node is already visited, so I can come here, come back here. It's already visited. It shouldn't be in the traversal once again. E is already in the list. B is already in the list, but I know that E has a sibling. So that's why after P, I will continue with F. This is sibling of E. And then if you look at parent of F, it's already visited. So now this part is completed. So I can now start visiting the siblings of B. So I will continue with C. And then I don't have another option. A is already visited, and I have T3 of A. So I need to continue here. And then D has some children. So I will start visiting T1 and T1 of G. So L is already visited. Now we don't have anything underneath. So I need to visit sibling of L, which is M here. So I will now go back since we don't have anything underneath again, or T3, we don't have T3 of G. So what we do, we continue visiting siblings of G. So I will switch to H and then I. Now, is it finished? Are we done? Yes, we are done since we have visited all the nodes. If I write it here, it's A, B, E, J, and then K, N, N, O, P, and then we jump to F, and then C, D, G, L, L, M, and then back to this level H and I. So this is the pre-order traversal of the given tree. Any questions, guys, about how we do the pre-order traversal? Then I think everything is clear. We can switch to the next type of traversal. So this is actually what we have done, the summary of the methods, the steps. And as you see, this is exactly what we have obtained here. This is the result of pre-order traversal. And then we have in-order traversal. And again, we have the same example, but before that, I would like to focus on this definition. If you remember, this first part of the definition is stating that if you have a single, let's say, I'm sorry. Oops. Yes. If you have a tree with a single, let's say, root R, then we can say that R is also the in-order traversal of the given tree T, since we don't have any other children, another connected node. So we can say that if you have a single node in your tree, then it's already the in-order traversal of your tree. But otherwise, in the in-order traversal, what we are doing, again, we will assume that there are some children starting from T1 to Tn. So here is the rule. The in-order traversal begins by visiting T1 first. So T1 will be the first item. And then we will visit the parent, which is R, and then continue with the remaining siblings of T1. So that will be the in-order traversal of this simplified tree. And if you look at our example, it should be B, A, and C, D, if you just consider this part. Okay. Now we will try to write the in-order traversal for the whole example. So we should follow the rule. The rule says that the in-order traversal should begin with visiting the leftmost subtree. So if you start from the top, this is A, and it shouldn't be the first one. B might be maybe the first item in the traversal, but since B still has some T1s underneath, E has another T1, so we will start with J. This is the bottommost T1 of our tree. That's why you'll be visiting J first, and then according to the rule, once you visit T1, then you should be visiting R, which is the parent of T1, and in our case it is E. So that's why you'll continue like this. So then what we do after visiting E, we need to visit actually siblings of J. But in our case, since we have children of K, so I cannot directly continue with K. Instead, I will continue with T1 of K. So that will be the next item in my traversal. And then since this is T1, this N is visited now, and then I need to visit R. So R of N is, in our case, in our example, K. So that's why I continue, I'm sorry, here, K. And then according to our rule, after parent is visited, we need to visit the siblings. So that's why we will continue with O and then P. So then what's next? This part is already covered. We have visited all the vertices here, all the nodes here. And I will go back and I come to this point B. I can visit it since E is already visited. E is T1 of B. So B is the parent of E. So I need to visit it. And then I should continue by visiting the sibling of E. What is that? It's obviously F. Now this part is completed, and we can say that this part is, let me have a circle here. Except L, please disregard L here. This is T1 of A. And this is T2, and this part is T3 of A. So T1 is already visited. Every node in this T1 has been visited. So we need to visit R, which is the parent of our node here, B. So we were stopped at F, and then from F, I will directly jump to A. This is parent, as I mentioned. Now parent is visited, and we need to visit siblings of B or siblings of T1. The first one is C, so I visit C. And then what I need to do, I should jump to this rightmost sibling, which has some number of nodes here. I can continue with D, but I see that it has children, so I need to go into deeper. We have the leftmost children, G, but it still has 2 children, so I need to go one more level down. We have L and M. So I need to visit L, so this is the leftmost subtree. So after C, I should jump to L. And then what I need to do, I need to visit the parent of L, which is G. And then I should continue with T2. T2 is M here. So M is visited. Now I can go back. Now, if I come here, G, T1 of D is already visited. So I need to continue with the parent of G. Who is that? It is D, obviously. Now parent is visited, and I need to visit the remaining siblings of G. So what are they? H and I. So now my in-order traversal is completed. I can maybe write it here so that it will be much better. We start with J, the leftmost subtree item, then start visiting the parent of it, E, then children of K here, and K, since K is the parent, I need to visit K, and then the other siblings, O, P, and then that part was over. We jump to B here, since B is parent of E, and then I visit T2. T2 is after this part is completed. I can continue with the parent of B. Since T1 is completed, parent of T1 is A. And then we have another T2 of A, which is C, and then we will continue with T3, but T3 has many children, so I go deeper. We have L, G, M, and then this part is covered, so I need to visit parent of G. After M comes D, and then the other siblings, H and I. So this is the in-order traversal of the given tree. Any questions, guys? If there's no question, then I think say that everyone has understood the basics of pre-order and in-order traversal. Okay, we can switch to the next type of traversal. This is what we have done here, the steps. And then we have the last type of traversal in this category. We have two more, but they are a bit different. So in this post-order traversal, the basics are similar, but the rule is a bit different. Again, if you have a single item in your tree, you can say that that single item, that single node is also the post-order traversal of your given simple tree. But if you have many, then the thing is that this is the rule actually. The post-order traversal begins by visiting T1. So if you have, let's say, R and again some children, T1 to, let's say, Tn. So it will start by visiting the leftmost subtree T1 and then the other siblings T2 up to Tn, and then this traversal will end by visiting our root, which is R. Okay, if we again use the simplified part, that will be the post-order traversal, B, C, D, and A. Okay, now let's try to obtain the post-order traversal of the same tree. So we should again look at the rule. It says that you should start by visiting the siblings of R. But again, once you are doing the visiting, you should always consider that visitings will be in post order. So if I start from here again, B is the sibling, I may continue, but I see that there are some children. So I go to deeper levels and I see that that should be the starting point. What will be next? According to the rule, it says that the next should be the sibling of T1. Sibling of T1 is T2, as you see here. It is K, but according to the rule, we should continue visiting in the post-order fashion. So we need to visit siblings of K first, and then K itself. So I need to switch to N here, and then to O. This is T1, T2, and T3 of K. And then after all the siblings are visited, according to the rule of post order, we should end this visiting by visiting the root. What is the root here? It is K. So we have K here. And now let's discuss the next item. Now these 4 are already visited, and we have visited the root. So I can say that children of E are already visited, J and K. So according to the rule, once again, we should visit the root here, which is, what is that? It is E. So E is visited. And after that, we are now at this level, and we shouldn't be visiting the parent. According to the rule, we should be visiting the sibling of E, which is F here. Now these 2 children, these 2 siblings are visited, so we should visit the parent according to the rule. B is visited. And now, again, according to the rule, this sibling, this large sibling has already been visited, so I need to continue with other siblings. C, and then if I come here, I cannot continue with D, right? Since I need to first, according to the rule, visit children, and then siblings of that specific child, and lastly, the parent of that, let's say, group of children. So after C, I need to go actually downwards. We have G at the leftmost part, leftmost child as the leftmost child, but it has also 2 children, so I need to go further. So this is L visited according to the rule, then I need to visit sibling of L, which is M. After M, I need to visit parent of these 2, which is G here, and then siblings of G should be visited, H, and then I. And lastly, since these children are already visited, so I need to visit the parent, D. And lastly, since all these children are visited, the last item in our traversal will be the root itself. So that's it actually. Let me write it here, J, and then we switch to NOP. And then K is the parent of NOP. And then we have E, and then F, and B is their parent. And then we have another sibling of B, which is C. Then I switch to T1, T3 of A, and I need to start with L. Sibling of L is M, and then their parent G. Its siblings H and I, their parent D, and the last parent, the root is A. So that is the post-order traversal of the given example. Okay, guys, let's continue with the spanning trees. It's a bit different topic, but somehow related to the traversals. Assume that we have kind of a graph, and this graph is called as G, and we are trying to find the spanning tree of that graph G, and obviously it will be the part of that graph G. So we can say that the spanning trees are the subgraphs of G, and the thing is that about the spanning trees, they should contain each vertex of G. And if it can only be connected, the given simple graph can only be connected if you have a spanning tree. Otherwise, we cannot say that this graph is, the simple graph is connected. So now we will actually, let me show you, you can assume that here, this is our original, let's say, graph. And now what we are doing, we are removing some parts, some edges, so that at the end of it, we will obtain a spanning tree. Since if you remember in the definition of tree, we said that there shouldn't be any circuits, right? And we have 2 more here, so we cannot say that these 2 first examples are the spanning tree of the graph G. Instead, we need to somehow eliminate these circuits by removing some edges. Here you see this first one is removed, and then we remove EF here, and then lastly remove GF, so that we don't have any circuits in our graph, connected graph. As you see, it's still connected, but we don't have any circuits, and we are visiting all the vertices. So I can say that this is a spanning tree of the given graph G. So what do we have here? We have some other examples of spanning trees of G. So we don't have a unique spanning tree. We may have many examples, as you see here, but the thing is that you should be visiting all the vertices. In all these subtrees, that's the rule. All the vertices are visited, and we have unique spanning trees. I'm not sorry, not unique, but many spanning trees. And obviously, since it's a tree, we don't have any circuits inside. Any questions, guys, about the spanning trees? Now we will be using it in the other types of traversals or kind of search methods. So we have two other search methods for the trees. The first one is depth first search, and the other one is breadth first search. We will be using this type of search to actually construct the spanning tree of the given connected graph. So what we are going to do, as the name implies, we will try to go to deeper as possible. So we don't want to go at the same level. We would like to go as deep as possible. So this is actually how we do. You may start with any point here, any node, if this is your graph. And then our aim is to find the spanning tree by using depth first search. So this is our root. This is already given. So we need to start with F. And then what I do, you may start visiting any of these. It doesn't matter. But the thing is that you should always try to go as deep as possible. And then we have some options, but I select going into this direction. This is G. And after G, I don't have any other options. So that will be H. And then I may go to I, but that will be a shorter, let's say, search. So I want to go as deep as possible. So that's why I prefer to visit K next, and then obviously J. So after you reach to the deepest point, what do? You simply come back. You come back, and here you see that once you come to the node H, we have an unvisited node, which is I. So that's why, as you see, we are gone as deep as possible, and then we are going backwards. But at this point, H, we see that there is an unvisited node of H, or an unvisited child of H. That's why we visit I. And then let me do the same thing here. We are visited back. I is visited, and then I need to come back once again. I'm going back again in my tree to G. Since H is visited, F is visited, G is visited, I need to follow the same path. And then to F. And now, once you are at F, then you can have two other options. Since these are not visited, you may visit D. D is visited, and then continue with E, continue with C, and then to, let's say, A. And now you're again at the bottommost point of that part. So what you need to do, you need to go back. Once you go back, you will realize that there's a child of C which is not visited, so we should visit B. And then once again, come back. And I see that this is already visited. We don't have any unvisited, let's say, children or not. And then I continue going back. Now I come back to the root once again, and I can now say that all the nodes are visited, and this is done. We have obtained the spanning tree. If you look at the initial graph, this is obviously not a tree since we have some circuits inside. I cannot say that it's a tree. And by using that first search, we obtain this spanning tree. And we said that in the earlier slide, we don't have usually unique spanning trees. We may have many options since we have some, for instance, once you come here, you have an option of, let's say, visiting B or A, it doesn't matter, or from F, instead of going to D, you may first go to F, E, and then D. In that case, let me draw it actually. This is F. I'm not going to change the left part, but let me draw it. This is H. I have I here. But after F, instead of visiting D, I may be visiting E. So if I visit E and then visit D, I need to go back once again to E and then continue with C. And then after C, it doesn't matter. I may have such a case. So as you see again, this is another spanning tree of the same graph. So I can say that spanning trees are not unique. You can have different versions, even by using a single method like that first search. Any questions, guys? Then we have a bit similar version, similar type of search. We can also obtain the spanning trees by using breadth first search. This is the example actually. Now instead of going as deep as possible this time, we will be going as much as possible at the same level. And we will be starting with E. Let me do it here. E is selected as the root, okay? Then the thing is that I need to visit actually all the vertices connected to E. So what are they? I have 4 nodes. So I can say that this is D, I, F, and B. So let me mark them here. These 4 siblings, 4 children of E are visited. Now I don't have any other options, so I need to continue with the children of these letters, D, I, F, and B. So let's continue from D. D has 2 unvisited actually, let's say connections, so I can connect A and F here. Let's make A here and put H here. So these are visited. And then I need to check the connections of other, let's say, siblings of D. For I, what do we have? These are already visited. I need to have J and K. J, K. Okay, for F, I may have C and G, right? I have C and G. For B, do I have any unvisited connections? No. So that's actually all for this level. Then I need to go one more level down. So we have an M, which is connected to K. This should be M. And then I have another unvisited node L, which is connected to G. So that's an example of a spanning tree, and we have obtained it using breadth first search. So the aim is to visit all the nodes at that level and then go one more level down, but we don't need to go as deep as possible. Any questions, guys? As you see, this is, I'm not sure, but it shouldn't be the same, right? Yes. The clear hits is not the same as we have done a moment ago. So we can say that once again, the spank trees are not unique. You may have many of them depending on the configuration of your tree.